Hello everybody. Today we are going to start a series of experiments in which we will look at the 5 reaction types. Up here on the board are the 5 reaction types that we are going to be working with. We have the reaction type, the name of it, and the general form. The A plus X reacts to form AX. This general form is what you should be looking for in order to identify the reaction that we are doing in the lab. Also, under the reaction type is the distinguishing characteristic. How can you identify that this is a synthesis reaction, for example? And that is, for the synthesis, one product. If we find a reaction that only has one product, this A plus X reacts to form AX, just one thing, we know that it is synthesis. Decomposition. We know it is decomposition if it has one reactant. Remember, reactants are on the left side of the arrow, products are on the right. So if you have not copied this down from a previous experiment or from a previous lecture, you should stop the video now and copy this all down. Another thing of note, for the single and the double replacement, the E and the C stands for element and the C stands for compound. So stop the video if you would like, and then we will proceed. One thing I want to mention before we do our first experiment is a test that we will run on multiple occasions during this time, and that's the burning splint test. A splint is a piece of wood that we will light on fire, and we will test it. You'll see in today's experiment, plus another one, how we test it. But after we test it, if it stays on fire, if the splint stays on fire, that means there is oxygen present. It's continuing to burn. If the fire goes out, that means carbon dioxide is present, CO2. So just a quick little information on what that test does and what we look for. Now let's take a look at our reaction for today. So here is our board that we will be filling out. You should stop the video right now and copy this down in this form by leaving space for a reaction up here, the general form, the A plus X and so forth, the name of the reaction type. We have a couple of data tables here with what the reactant and the products will look like, and then a space for a description and an observation in the middle. So stop the video, copy this down so you're ready to go. So let's take a look at this experiment. We have one reactant, NaHCO3. This is baking soda. Hopefully you're familiar with baking soda. You use it in the kitchen for baking. So we have one reactant. So the general form then, for this reaction here, we have one thing that we're starting with. So one thing that we're starting with, we can just call it AX. The reaction type is based off of that one reactant. We just saw on our previous overhead here, our previous thing on the whiteboard, that one product, AX, reacts to form, is a decomposition reaction. So that is what we have. We have a decomposition reaction. So where it says reaction type, we will write decomposition. And we know that the general form is AX reacts to form A plus X. So we are going to have 2 or more products when we do this reaction. So let's go ahead and do the reaction. So here is our setup. What we want to do is get our Bunsen burner going, because we will need to decompose this baking soda, so we'll get that going. And here is our baking soda. Take some out, show the camera a little bit. So we can see that it is a solid white powder. We are going to have to describe what this looks like. So that is going to be our description. What we want to do then is take some and put it in our test tube. I want to make sure we have a test tube clamp because we don't want to touch the glass when it's decomposing. It's going to be pretty hot. So now what we want to do is put the test tube in the flame. Tipping it off to the side a little bit, moving it around a little bit so it starts to decompose. And now let's take a quick look at this test tube. Look at that test tube. It's kind of foggy inside. That's condensation. So it looks like a kind of a transparent liquid of some sort. Should be obvious that the most obvious choice for a product then would be water. Transparent liquid, most common one is water. So we'll decompose it a little bit, noting that water will be one of our products. And so now it's decomposed for a little bit. We are going to conduct a burning splint test. So we can take our splint, light it, and take our test tube, put it in there, and it goes out. So since it went out, we know that there is carbon dioxide present. So carbon dioxide and water looks like will be two of our products. So let's go back to our board up here and see what we have going on. So let's fill this out then. So what we have is our reactant: bicarbonate of soda, sodium bicarbonate, baking soda. Description: we want to write what it looks like. We said it was a solid white powder. So that's good. We also had some observations that we made. What happened? We saw that water went on the side of the test tube. And the splint went out. So those are the two things that we noticed. That there was water present on the side of the test tube, so one of our products will be water. We also noticed that the splint went out, so we also know that carbon dioxide, CO2, is another product. And actually, instead of writing down the word water, we can write the formula, H2O. And now we can write descriptions of these. Na2CO3, that was one of the products that we came up with. There's no good test for that we are going to do, but that is one of the products. And as you saw in the test tube, that it looks the same. It is a solid white powder. So it looks the same as the reactant. So we'll write the same thing. Solid light white powder. Water, transparent liquid. So we have a transparent liquid for water. And carbon dioxide, we could not see it. So we can just say invisible gas. So we have an invisible gas for our CO2. And now we can complete our reaction on top, since we have all of our products listed here. Na2CO3 plus H2O plus CO2. And now we have our data table figured out, all filled out. And now you can go on to Schoology and answer the few questions that are there. Have a good day.